Now, special relativity is really an amazing subject. For me, when I took special relativity, this was the first time that I encountered something that was completely unintuitive. And by that, I mean that the conclusions which we're going to draw from special relativity are going to be things we never see in our daily lives. And that's because special relativity deals with the realms of the very, very fast of objects moving near the speed of light. The speed of light is such an important number in physics that we give it its own variable. We call it lowercase c. And its value is about 3 times 10 to the 8th meters per second. In fact, the exact value is 299,792,458 meters per second. But this is the approximation we're going to be using in this unit. All right, so I've told you how crazy and mind-blowing this topic is going to be. Where do we begin such a topic? Who do we start with? What do we talk about? Well, let's start with our good friend Galileo. Now, you may have heard that special relativity is Einstein's theory, Albert Einstein. And yes, that's true. But just like Newton before him, Einstein stood on the shoulders of Galileo to make his, or at least one of his, amazing discoveries. In fact, his theory of special relativity can be completely derived by 2 postulates. A postulate or axiom is just something that we believe to be true and which we use. We use these postulates by applying logic to them, and eventually we get some conclusions. What's pretty amazing about this approach to problems is that as long as the logic is sound, you can't argue the conclusions if you believe the postulates. What I'm going to do today is show you what these 2 postulates are, motivate why they must be true, then we'll see a couple of the remarkable conclusions that fall out. Let's move forward to the first postulate.